Hello everyone, welcome back to the another session in Design and Analysis of Algorithms, Unit 1, Topic 5, Analysis using Recurrence Relations. Prior to this video, we were discussed about how recursive algorithms will get executed and what is the time complexity by drawing the tracing tree, correct? And now this video is mainly focusing on recurrence relation. How to find recurrence relation. Now, let's see about this same recursive algorithm, what we were taken as sample in the last video. Now from this, we'll take some recurrence relation. So, if n greater than 0, this will take 1. Unit of 1 time to execute this. Void test is what? It is a function and now I'm representing this function with t of n. So basically it is f of n. Function is f of n, but I'm changing into t of n, keeping in mind that I'm going to find out recurrence relation. So recurrence relation of this function is what? T of n. So t of n is what? For int n function. Test of int n function is t of n. The time complexity or the time which is required to execute this function for n value is t of n. Now if n greater than 0 will take 1 unit of time. Printf also will take 1 unit of time. Now look at this. Test of n minus 1. If test of n is required t of n time, then test of n minus 1 required t of n minus 1 time. Finally, t of n is the total time which is required for this test function is t of n. That is equal to t of n minus 1 plus, if you add this one, it will be 1 plus 1 and this is what? 2, correct? T of n is equal to t of n minus 1 plus 2. So this is what? Constant time. It may be of 2, it may be of 1, it may be of 3. It is what? Constant time. If you remember the first video of this lecture, there we were discussed about frequency count and line count method. So in that we understood how to calculate the time complexity. So there we wrote one point very clearly. This constant time, whether it may be of 10 also, we were treated as 1. So I am taking this 2 as 1. So finally t of n is equal to t of n minus 1 plus 1. So this is what? Total time complexity for this algorithm. Okay. And now we'll take this relation in the next slide. Now we'll take this. Okay. So t of n is equal to t of n minus 1 plus 1. So this is what? The time complexity for n value. Now we'll write this. Total time complexity is equal to t of n minus 1 plus 1 where n value is greater 0. If n equal to 0, in the algorithm we wrote very clear algorithm. The test function is having one value. Now if n is greater 0, then only we'll print n value, correct? So that only in the algorithm in the previous slide, and other continue to that, we'll call this recursive function. So what you noticed, when n value is greater 0, then only this is going to be happen. So the time complexity for this is what? T of n minus 1 plus 1, correct? When n value is greater 0, printf function will take 1 unit of time, test function will take n minus 1 time. So when n is greater 0, the time complexity is what? t of n minus 1 plus 1. When n is equal to 0, now assume that n value is 0 over here. When 0 greater 0, condition fail. When condition fail, where we'll go? We'll come out of the loop. So only this function, only this statement will get executed. So the total time complexity of this algorithm when n equal to 0 is 1. So the recurrence relation is what? T of n is equal to 1 when n value is equal to 0. T of n is equal to T of n minus 1 plus 1 when n is greater 0. Now, we'll solve this recurrence relation. T of n is equal to T of n minus 1 plus 1. So now, if T of n is T of n minus 1 plus 1, what is about T of n minus 1? So, apply substitution method. Substitution method. Now, you can see here T of n, right? Now, in the place of this T of n, substitute n minus 1. N minus 1 minus 1 plus 1. That becomes T of n minus 2 plus 1. And whose value is this? T of n minus 1 value. T of n value is T of n minus 1 plus 1. T of n minus 1 is T of n minus 2 plus 1. Now, T of n minus 2 will be T of n minus 2 and minus T of n minus 2 minus 1, right? So, and plus 1, that is T of n minus 3 plus 1. So, whose value is this? T of n minus 2. When T of n minus 2, now the value is what? T of n minus 3 plus 1. So, these are the values what we have. Let's find out the recurrence relation. Now, I'll take one more slide. Using substitution method, T of n is equal to T of n minus 1 plus 1. So, use substitute method. Use substitute method. T of n is equal to T of n minus 2 plus 1. Okay. Now, T of n is equal to, we found T of n minus 2 value in the previous slide. T of n is equal to T of n minus 2 plus 2. Now, T of n minus 2 is what? T of n minus 3 plus 1 plus 2. Finally, T of n minus 3 plus 3. So, if you continue this task for k times, T of n is equal to what? T of n minus k plus k. Correct? Now, if you see that k times, now what happens about this? T of n is equal to, when k value will reaches to 0, T of n minus n. That's what? When k is equal to 0, what happens? N minus k is equal to 0, n is equal to k. Now, n minus n plus n. T of n minus n is what? T of 0 plus n. Now, T of 0 is what? T of n is equal to, T of 0 is 1 plus n. So, finally, T of n is equal to 1 plus n. And this is what we got in the recursive algorithm time complexity. In recursive algorithm time complexity is what? N plus 1, correct? In recursion tree we were seen in the previous video. So, through recurrence relation, time complexity is what? 1 plus n, or else n plus 1. So, this is the way how we have to solve recurrence relation. Thank you all.